Thank you. Okay, so you haven't figured out I'm the one that likes to make jokes and entertain everybody. So first off, who here has done graphing? Okay, good portion. SGplot versus GTL. Oh my goodness, you are in for a treat because the whole thing is about GTL. So we're going to show you how to go from SGplot to GTL. All right, so we're going to turn it over to Louise. Louise is going to go over the agenda and start off with some of the general syntax.
Well, welcome to our talk, and I hope that you learn as much as Richanne and I did putting it together. So up on the agenda is general syntax, and we'll go through a stacked bar chart and a map of the New England states. We told you there was going to be a map, and there is going to be a map. And then we're going to do side-by-side plots in GTL, and then the conclusion. So at least one plot statement is required. And there are several plot statements. Too far? Okay. There are several plot statements that can be used with SGplot. For a complete list of plot statements, refer to the SAS documentation. For this presentation, we're only going to talk about the bar chart and the polygon plot, which is the map. GTL is a two-step process. The first step is to define the structure of the figure or plot using proc template. Even though you've defined it, proc template does not itself create the output. You need to associate that defined structure with the data. This is the second part. We use SGRender, proc SGRender, to associate the template, i.e. the defined structure of the plot, with the actual data that'll be used to generate the plot. First step is to creating a custom template is to define the structure of the graph. This is done using StatGraph. Each custom template will start with define StatGraph template name, which allows the user to provide a name for the custom template. The template name is used when rendering the graph. That statement has a corresponding end. Each stat graph has at most one begin graph, which is the signal that indicates the various components of the custom template are specified within the block. Begin graph has a corresponding end graph, which signals the end of the graph template definition. Layout allows you to specify the type of layout that you want and assign the necessary options. Layouts can be nested depending on whether lattice, gridded, data panel, or data lattice is used. For each layout, you need to signal the end of the layout with end layout. You see the pattern going with begin and end? And the majority of the work will take place within the layout blocks. Depending on the type of layouts and plots will derive how this portion is programmed. If there are multiple layouts or nested layouts, then there needs to be a corresponding end layout for each. As many plot statements and their corresponding options need to build the graph should be encompassed within the corresponding layout. The general syntax for proc SGRender is that we use the data option to specify the input data set. We use the template option to now associate the defined structure to the data. These are the two required statements in order to produce an association to create the graph. Additional SAS statements such as by, where, format can be used as well. Both the overlay and gridded use similar syntax. They differ in regard to the options that can be used. We need to specify the layout type and any options associated with that particular layout. In addition, for each layout specified, it needs to be terminated with end layout. Add any specific GTL statements needed to produce the output. Inner margin is only for overlay and prototype, although we will not be discussing prototype during this talk. Lattice is a bit more complex. With the lattice, you need to specify the options. Whoops. Wait a second, this is you, right?
That's the old one, go ahead. Finish.
Yeah. The option for each column axis, if the graph area is divided into columns, the options for each row axis if the graph area is divided into rows, and the other options such as column and row headers and sidebars. Note the ellipsis represents the GTL statements. We will be touching on the layout lattice in the last example, but we'll not be going into a lot of details regarding several of these statements. The complexity of lattice can lend itself to a full day of learning. And now I'm going to turn that over to Rich Ann, who's going to talk to you about our bar chart.
Okay, so we're going to start talking about bar charts, and here we have a stacked bar chart. You can have a vertical stacked bar chart, or you can have a horizontal stacked bar chart. When you're using SGPlot, you're going to use V-bar for vertical or H-bar for horizontal. And in this particular one, we are using what we refer to as segment labels. These are our segment labels where we're indicating the population for each of those states, and the states are identified in our legend. So we're using segment labels to identify that information, and we're just now going to stack them. And so we see the cumulative population over for 2020. It's about 15 million for the entire New England region. And so we are using the New England set of data that is in the SaskHelp states. I believe it's called states. SaskHelp.states. The SaskHelp.states data set is a very wide data set. Lots of data in there. We are only using a very small portion of it, and we transposed the data because, as I said, it was a very wide data set, but we had to make it so it was one record per year rather than having one record per state with all of the data on one row. So this is the data that we have produced. It's just a simple transpose of the data subsetting for the Northeast region. So to produce a bar chart, here is what we are using in SGPlot. So as I said earlier, wanted to know who was using SGPlot. Most everybody's using SGPlot. The goal is that we want to take what you already know how to do. So most of you know how to use SGPlot. We want to show you how to take that information, that knowledge, and convert it to GTL. Now, who has actually seen GTL proc template? Who here is afraid of proc template? Okay, so we're going to make it not so scary, but we're going to start off with the SGPlot. So the first thing we're going to do is there are different types of statements you can provide within the procedure. We have a format statement, but we also have what we refer to as a style adders. That is the attributes, and so most of your attributes are going to be inherited from the particular style that you're using. So if you're using ODS, I believe the inherited style is, ODS PDF, the inherit style is Perl. If you're using RTF, the inherit style is RTF. So we, by default, automatically inherit those styles. We may want to change some of them, and because we're scared of proc template, we're going to just do it right here in the style adders by controlling the colors. So here we're controlling the colors. We're sending in 6 colors. It's a macro variable that contains 6 different colors. We're then going to use the V-bar statement. So as I mentioned, we can use V-bar for vertical bar charts or H-bar for horizontal bar charts. You have to have your category variable, and then we have a response. We want to group it. So if you recall, we had stacked bar charts. So to get that, we're going to group it, and we're going to group it by those state codes. We wanted those segment labels, and so to get those segment labels, we have to use the option seg label, and that's telling it to put the segment labels for each of those states within the segment itself. Seg label adders is going to control those attributes. And again, everything, all these attributes, your style is going to be inherited from the style from the ODS destination that you're using. We want to change some of that. So rather than creating a whole new style, we can change it directly in the proc SGPlot ourselves. And then we're going to control the bar width. The bar width is how much of the area the bar is going to take up. By default, the bar width is about 0.8. And so if you have 0.8 and you don't want it as wide, you can change that bar width. You can change it to 1, and 1 is going to take up the entire, what I refer to as a bin. So when you have categorical data, you have this whole bin of area to put your information. So right now, the default is 0.8. We're going to change it to 0.7. And that's going to give us gaps between our bars if we want gaps. And then we're having our outline adders. Oops, I didn't highlight that one. Our outline adders here is controlling the outline of the bar, and we're going to control those attributes as well. So you can see that you can control different attributes throughout the, with different options depending on what you want to change from the defaults. Easy, right? We're not even done with the SGPlot statement. We're still now have to control, talk about our axes and all of the other information. So here we're going to specify our x-axis statement as well as our y-axis statement. And this is going to allow us to control what kind of information is being displayed. So on the x-axis, we're saying no label because we didn't want to have that information, but we want the values. And so the no label is whether or not we're putting some kind of label along the side, that's the axis, along the bottom. And then, but we want those values, like the years that we had at the bottom, we wanted those bolded. For the y-axis, we're going to go from 0 to 16 million, I think that's 16, by 10 million. And so that's how we get our tick marks. And so we're going to use that values to get our tick marks. We're going to control the attributes again. We want them bolded, so we're just going to specify that with the value adders, give it a label, and again, control that label attribute. We want that legend at the bottom, so we're going to specify how we want that legend. That legend is going to be at the very bottom, so we use key legends. We want it to have the title of postal code with all of the values in bold because we want it to stand out. Otherwise, it's, again, going to inherit from the default destination. Now, as I've mentioned, if you wanted it to be a horizontal bar chart, stack bar chart, you're just going to change H bar, and you're going to change the X and Y axes. And that's a simple fix for that one. So creating templates. So figured out all of that. That's great. Wow, we love that. But we want to know about how to do this in GTL, correct? Because everybody who is not using GTL is afraid of GTL. I learned how to program graphs in GTL. To me, SGPlot is difficult because my brain does not think that way. So I'm actually the opposite. I'm more afraid of SGPlot, and I love proc template. So let's see how we create templates. As Louise was saying, this is our proc template, the general syntax. And again, people get really scared of all of that. The easiest way to learn proc template, I'm going to show you this really quick, slick way to take all of our SGPlot code that we just did. We're so proud of it. It gives us the graph exactly the way we want it, but we need to put it in a proc template. We're just going to use template out. Template out, that will write all of the code that is sitting in the background to write it into a proc template procedure. So it's going to create that for you. Now, file name has to be the full file path. So if you're saving it, say, on a particular drive, it'll have to be that drive name, the file name, dot whatever, dot SAS, whatever you want to call it. So it's the full file name. But that's simple. So if you want to save your template, so now that you've got your beautiful template, you want to save it so that other people, you're so proud of your work and you want to, hey, look, go use this. This is awesome what I've created. You don't have to do it. I've already done all the hard stuff. You can save it, and you can use that by using ODS path. And you'll see up here, I'm saving my templates to a live name of Adam temple, and then I'm going to say update, saying I'm updating that registry. I'm going to update that template store so that I can, sorry, didn't mean to do that, so that I can save it for other people in my company to use. So now we're going to go with the stack bar chart. So y'all want to see what the code that SAS generated for us? You ready to see it? Here's your eye chart. That is very difficult to read. It's horrible to read, but it works. This code will produce the stacked bar chart using GTL. And I know Susan was like, I can't read that slide. Can you fix it? And I go, no, the whole point is to show you what SAS has given us. So it is very difficult to read, so I'm going to put it in a little cleaner format with all the proper, indentation and all that stuff. I cleaned it up a little bit. Now, one of the things is that you're going to notice in here, as you're learning GTL, and I just know because, again, I'm afraid of SGPlot. I like GTL. I knew exactly what I refer to as extraneous code. What you have to keep in mind is SAS is trying to build your template so that it probably can be dynamic and be used for other types of data. If it's a one-time use, then I'm going to go strip off all the extra stuff. So I'm going to show you where some of this extra stuff is. So here, this dynamic negative, dynamic tick list, this information is saying that we're going to feed it some dynamic information. Well, we don't have dynamic information. It's all static. We're using the SAS help.states data set, so it's static information. We're not changing it. We're not going to use this particular graph for anything else, but if you were, then you're probably going to want to have some kind of dynamic variable in there. But I'm going to strip it out because I don't need it right now. This correlate equal binary, that is an undocumented option, so I'm deleting it because it's undocumented. I don't need it. And again, because I know proc template, I know what's not documented and all that other good stuff. You'll learn as you're starting to learn template, you're gonna start seeing things that are, wait, that doesn't make sense, that doesn't make sense. And some of it's just gonna be a lot of trial and error, but now you have a starting point, and that's the whole thing, is you have a place to start with. Now start going through this and saying, I don't need an entry title. And I'll explain why we don't want this entry title. We do want a title, but we may not want the entry title embedded directly into the graph area. We may want that title outside of the graph area. If you want it in the graph area, then keep the entry title. But if you want it outside of the graph area, then get rid of the entry title and use a title statement. The other things are, we didn't use the Y2 axis. We didn't use X2 axis, and then for some reason, SAS split the Y2 axis options onto two separate lines. I'm not quite sure why, but you can combine that. So I'm going to get rid of all that. And then here, they used bar chart parm. One of the things I did not talk about previously, with the SG procedures, the SG plot, there is a V-bar parm and an H-bar parm. Those are when your data is already pre-summarized. If your data is pre-summarized, you would want to use the parm because the data is pre-summarized. If you're using V-bar or H-bar, the data is going to get summarized in the procedure. Same thing's going to happen with proc template. SAS was smart enough to know that the data was already summarized. So in this instance, I could use bar chart or bar chart parm to produce the graph. Now, one of the other things, I'm not sure if y'all can tell and see this here, this Y in quotes with an N, that is using the valid var name equal any. Who's used that? Okay. So that means you're allowed to have spaces in your variable names. Don't want that. We don't have spaces in our variable names, so I could strip that and just change that to year and change it to my population value instead of using the little valid var name equal any option. So that I'm going to fix as well. Primary equal true. That's if you have more than one type of plot statement and they're going to have the potential of having different values on the axes. We only have one plot statement, so I can get rid of that. Again, all of this is things that you're going to start getting familiar with, and some of it is like, does that make sense? Can I delete it? Or I'm going to leave it in there because I trust SAS and I'm not sure what I'm doing. And again, this legend label here, this legend label is not going to be needed because we're going to actually provide a discrete legend title. So we're going to get rid of that as well. So here, what SAS gave us was a lot of unnecessary code. Again, it still works. It's still great for learning. So once you've got your proc SG plot into a template, you can now figure out what to remove, and that may be extraneous information. So we're going to take that, and we're going to condense that code dramatically. So here's the condensed code. And do I have animation on here? So we cleaned this all up. Now, one of the things, I'm going to go back real quick. Look what SAS did. They listed every single tick mark. Okay, that's fine. That works. I want to shorthand this because, what if all of a sudden I need to go to 24 million? Do I want to list all the tick marks between 16 million and 24 million? I just have to change it here and here. And so what this is doing, this tick value sequence is saying, I'm going to create a list of tick marks starting at 0, going to 16 million, and each tick mark is going to be an increment of 10 million. Now, the view min and the view max is saying that I'm going to allow data up to between 0 and 16 million to show. That doesn't make a lot of sense in this particular graph. Now, just to give you an example of when I've used it, I've created patient profile plots where I have to draw an arrow, and I need that arrow to extend past the actual tick mark value. And so then I use the view min to extend my axes, the view max to extend my axes, but I'm only showing tick marks up to a certain value. So that's how you can get arrows going past your tick mark values, to use your view max to extend past that value. And so this is what we're producing with the template. Now, I mentioned entry title. This title up here is used with entry title, which means it's embedded directly into the graph. You cannot edit it, you cannot change it unless you edit your template. We don't want that, so that's why we're going to get rid of that entry title, because we want that outside of the graph. We want it as a title statement itself, so we're going to use it as a title statement. And so without the entry title, we're just going to strike that piece of code. And then now we have our graph without that title, and the title is now going to be sitting outside of the graph area. And so at this point, I'm going to turn it back over to Louise, because she is our mapping queen. So, oh.
I don't need it, continuing with the SG procedures, we're going to take a look at another form of SGplot that produces a map. There are actually two SG procedures that produce maps, SGplot with a polygon statement and proc SGmap. We will be using the SGplot procedure with the polygon plot because that works well with the GTL. So proc SGmap, like proc SGPy, does not create a template program to be reused at this point in time. The appearance of the maps created by proc SGmap and proc SGplot with a polygon plot are virtually identical in appearance, depending on whatever parameters you use. So if you're interested in proc SGmap, there are several papers in the references, but in the interest of time, we'll just move on with proc SGplot with a polygon statement. So on the screen, you see a SAS-created choropleth map of New England region states, a choropleth map that uses differences in patterns, colors, or symbols contained within the geographic regions to reflect different data or different ID variables. And here you see data values, population change in 2020, controlling the color of the states, and ID values, i.e. state abbreviations, annotated on the states. In order to represent data on a map, you need X and Y coordinates to draw both the polygons, for example, the map shapes, in this case, the state outlines, and to label specific data points, in this case, the centroids for each map shape. The data set shown on the screen is used to create our map, and it's created by combining the state-level data points, population change in this case, with geographic map ID variables, in this case, state or FIPS state code. The state variable allows linkage of geographic line data for the US states. And in this case, we're using a SAS-provided US state map, but there are many map files available on the internet with the data points. At the top of this sample data screenshot, there's 6 rows with XY coordinates for the centroids of each state, along with the label which we want to use. And you can see that there's missing data in some rows, and that's okay. We're just stacking up 3 different sources of data, and SAS knows which data points to use for which pieces of the visualization. So the data set used for a polygon map is combined. It's containing response data and spatial data as discussed on the previous slide. The offset min and offset max indicates how much space should be saved between the axis and the minimum and maximum value of the plot. For both the X and Y axes, the offset before the minimum value is 0.01, and the offset after the maximum value is 0. That just makes the spacing a little bit easier to look at. For maps, you don't usually want to see the X and Y axes. They don't really make any sense. So we set display equals none. If you don't explicitly turn off display, SAS will automatically try to create one. Like the V bar and H bar plots, we also specify the analysis or the group variable. The scatter statement effectively overlaps the state abbreviations on the centroid for each state polygon, and that's XCen and YCen. And then the key legend controls the legend, allows you to position and format and title the legend. And again, you'll find a lot of these sort of attribute statements in any SG procedure, and it's just very uniform. So sort order specifies the order of the legend items, the order that they will appear in. Without this, the order would be based on the order of the first plot statement, or if the data is grouped, as with the case with the polygon, then it is based on the data order. The AnyMap data set is sorted by state code, thus the value for the legend for MA change in population, i.e. 7.4, would be the second item and not the last. Note that the legend values are the formatted values. And the exclude statement under the key legend allows you to suppress the Y centroid and missing values. Notice the sort order of the legend. The graph looks at same, except that the legend is not correct for the image on the left. So if you look at the two sort orders, and that the effect of all the code that we used is to get that order correct. And just as we did with the bar chart above, we're going to use the template code generated by proc SGplot with a polygon plot to generate code that can be reused. This is the ugly version. As a reminder, this code is generated by using the temple out statement that Richanne just showed you a little bit earlier. And as we've seen before, this has some extra lines of code that can be removed to make the program more readable. This is a more complex map, so there's some new commands, such as the polygon plot statement, which has its own set of subcommands, such as outline, attrs, etc., that control the state outlines. And we'll see in the scatter plot information about tips. This is for tool tips. When you mouse over a state, you will get a pop-up with information that can be controlled programmatically. And this is the cleaned up version, way less dense. It's not much different from the earlier stacked bar chart example that we have shown, but it did remove the extraneous code. For the sake of space, we're not showing the proc SGRender statement, which actually draws the map, that this template, any underscore poly we just created, would need to be associated with the data in proc SGRender. And we're going to turn it over to Richanne again, who's going to tell you how to get the maps and the bar chart in the same place.
Yes, and so we want to do a side-by-side plot. This is our goal. We want to produce this particular graph. Who thinks this is going to be easy? Besides the people that program and, besides the person that wrote, graphing stuff. So we're going to produce this particular graph in GTL because, one, we've already know how to do GTL, right? By this time, we've already figured out how to write GTL. So before we do that, what I like to call is you don't want to get stuck in the gutters, and so we have to understand what this concept of gutters are. So when you have a multi-cell graph, you're going to have these little spaces between each of the cells. That's referred to as your gutter. How much space do you want between those graphs? And so you want to account for that. Sometimes you want those graphs touching, you want no gutter. Sometimes you want some space and you want to add a little bit of a gutter there. So this is a multi-cell graph, and if you have a multi-cell graph and you're using layout lattice, you have other things like sidebars, row axes, column axes. Sometimes they can be, the same axes across the entire row. Sometimes they can have different axes for each cell. And we're not going to get into that, as Louise had indicated. Understanding layout lattice could be an entire day of let's just talk about lattice. But we don't have that. We only have about 10 minutes left, and I want to make sure we get through this example. So This is going to come into play in a bit, this gutter. So I want to explain that. That's why I wanted to give you this high-level overview of what this gutter is. So our data, we're taking the data that we use to produce the stacked bar chart and the data that Louise used to create that New England plot, that New England map. We're just going to make sure we stack all this data together. You can only associate one data set with the template. So all the data that you need has to be in one data set. So you'll see that there's a lot of blank spaces, blank values here, blank values. SAS is going to figure out which row is going to be used for that particular plot statement. So all the data has to be in one spot, so you're going to have a lot of blanks. So that's fine. That's fine. Now, SAS will give you a warning if everything is blank and did not find any single row with values, it will give you a warning. Still produce a graph, but it'll give you a warning. But we do have data for all of our plots, so we're good. So here is our side-by-side plot in the gridded. So we're going to use a layout grid. So there's two ways to do this particular graph, layout grid and layout lattice. We're going to start with the grid. Now with the grid indicates that the cells are going to be the same size. And that's key. The cells are going to be the same size. Now here you'll see that on the right side of the graph, so order of specifying your layouts is important. If we want on the right side a particular, did I do this right? Nope, it's the, I got it backwards, didn't I? Hold on. Left, right. On the left side of the graph, so the order in which you specify these layouts is important. So it's going to fill it from left to right when you're producing it. So I got my little comments backwards. So if you want the map on the left side, you're going to do the first cell is going to be the polygon stuff. If you wanted the map on the right side, then you would do the first cell as the stacked bar charts. And so the order is important. So ignore my comment because I have them backwards. I have them correct here in the end. See? Left, right, right. I'm sorry. I sometimes just confuse myself. But anyway, Louise has already shown you all the stuff for the, can we hold questions to the end? Because we want to make sure we get through the whole presentation. But yes, we will he has a question back there towards the end. But Louise has already shown you the GTL for how to produce the map. We're literally going to pick that code up and drop it right here. I've shown you the code how to do the stacked bar charts. We're going to pick that code up, and we're going to drop it right here. And it's as simple as that. Now, the thing that we needed to understand is that we have to now take these two layouts, and we're going to nest them in that layout gridded. Now, within layout gridded, we're indicating that we have 2 columns and 1 row. So that means we have 2 cells. If we would have said 2 columns, 2 rows, that's 4 cells. So we only wanted the side by side, so two cells. And we have to specify that layout, as Louise had indicated previously. We have an in layout, in layout. Now this in layout goes to this grid all the way up here. And so we're just dropping all that code in there. And now we have this graph. Now this graph, in my opinion, looks a little wonky. The states look distorted. Some of the states are a little bit wider than they should be. And that's because with the grid, it's saying that the cells are exactly the same size. We may not want that. We want the stacked bar chart to have a little bit more space, and that way we can get the states to be a little more proportioned in the way they're supposed to look. The way we're going to do that is with lattice. And so with the lattice, rather than having the same size cells, we're going to control the size of each of the cells. So here with lattice, we still specify columns equal 2, rows equal 1, but now we're saying what are the weights of those particular columns. So I want to give 40% of the graph area to the polygon and 60% of the graph area to the stacked bar chart. You can adjust these weights until you get the right configuration and saying, yes, that looks correct, that proportion looks correct, and you would adjust that. Now here, I gave a column gutter of 50. Talked about not getting caught on the gutters. I'm going to show you why this is important. So this is going to add space between our cells. And we want to make sure we have that space between our cells because when I show you the example, you don't want things sitting like right up against each other because sometimes that can make it hard to understand where an axis label goes to which plot. And so here, oh, by the way, everything else is exactly the same. I didn't have to change any of this information or this information. I just copied it and dropped it all in there. Now, isn't that much easier? So when I was talking about the gutter, you'll see here, gutter equals 0. That state population is sitting right on top of that axis for the polygon plot. So then you're looking at it, well, which graph does it actually go to? So by adding that gutter, we're adding a little space saying there's this space between here so we can make sure that this label goes with this graph. And so you would adjust that gutter till you get it to the right space so that you know that, okay, that makes more sense. You don't want, especially when you're working with graphs with multi-act, like, you know, if you're doing Y2 axes as well, and you don't want the labels touching each other, you want to add a little bit of space. And so that's where not getting caught in that gutter. That's why I wanted to explain that to everybody, because that column gutter, and you're going to also have row gutters if you have multiple rows. So you want to adjust for that and allow for space between those cells if you need them. Sometimes you don't need them, but in this particular case we did, because we didn't want that label sitting on top of that, you know, Y2 axis of the polygon map. So this is over here. We didn't like that. It was too close to that. All right, so I'm going to pass it back over to Louise to finish up.
So in conclusion, we advise you to start with what you know, and that use temple out or the SG procedure. Build each component separately and piece all components together and modify as necessary. Producing graphs does not have to be a daunting task, as we've shown. It's just a matter of outputting what you already know, if it's SGplot, and using the plot arrangements, the lattice, and whatever to actually make exactly the graphic that you want, which may or may not include multiple graphs. And here is our contact information, and please feel free to contact us. And you all have access to the print version of this presentation. We have some references. I'm just showing you actually a lot of references. And please refer to those references because they were invaluable in teaching us how we could do this particular thing.
I did want to mention one thing that we did both forget to mention. If you notice in the polygon plot, which was the map, there were multiple statements. We had a polygon and a scatter plot. The order in which you specify those plots within the same layout is important. If we would have specified the scatter plot first, and then specify the polygon plot, can anybody tell me what would happen? Say it again? Yes, the labels would have been obscured because we would have written the labels and then we would have put the map right on top of it. And then we couldn't have seen it. So the order is important. So you want to make sure that you're not, if you need to have something sitting on top of it, then specify that after you do the polygon plot. And I believe this gentleman back here had a question.
Lower left?
It goes
Lower
left to
right, lower
You can
left.
specify the order. So there's row major and column major and a lattice that you can specify so that you tell it the order in which you want it to fill in. I believe by default it's row major. It goes across the row and then goes to the next row and then it goes to the next row. Any other questions?
Hello. So if we're working with an SGplot and then we're converting it with this temp out, and you said there's a lot of code that's kind of produced, like the entry title, when you remove kind of the unnecessary code, does it automatically save, or do you have to resave it as a template?
If you're saving it, like when I showed you how to do that ODS path, once you run that, once you rerun and compile the template, it will save it to wherever you saved the ODS path. So you will have to recompile it if that's what you're getting. Yes. So any changes you make, you'll have to recompile. Oh my God, no.
Wait. Can't get there quick enough.
When I said the person that wrote SAS graph is not allowed to say that they do graphs.
No, I was just going to just mention a couple tips. First, on dealing with the title, like Rich Ann said, typically in a shared template that you're using in your company, you don't want to hard code your titles, right? But there are good cases for having a title in there, especially if you can export your graph out. The title that goes on the outside will be part of the page, but you might want to have the individual image. So a good way to handle that is to put the entry title statement in there, but use a dynamic on the SGRender procedure. And what that allows you to do is, if you specify the dynamic when you run SGRender, it'll put it inside of your graph. If you don't specify it, it simply won't put the title at all, and you can put the title on the outside, like Rich Ann was talking about. So that kind of be a good flexible way, so you can go either way with that. The other tip I was going to mention was that for plots in general, it's really recommended to use layout lattice when you put them side by side like that. It gives you the most flexibility, as they were demonstrating. Layout gridded resizes itself based on its content. If you put like an entry in there, it'll shrink down to the size of the text. So that's how we actually create our little tables. If you ever use the inset statement inside of SGPlot, that's using layout gridded. And if you notice, every cells are based on the size of the text, right? So just as a general tip, layout lattice is great for any kind of plots like they were demonstrating up there. And like I said, you can give you the flexibility to change your weighting, your guttering, and all that kind of stuff. So yeah, that's what I mentioned.
I typically use lattice over grid, but I just like to demonstrate that you can use grid. Now, as he was saying with the titles, that sometimes you do want the titles in there, and I do use that entry title with a dynamic, and that way, like if I'm doing things, because I'm in the life sciences, I may want to produce a grid that's by parameter and visits. I want that title part of the actual graph, and so then as it's running, it's changing that title for every single parameter and visit combination that's running through it. But again, you have to use that dynamic option in your statement so that it will change it, saying that this data is not static, it's going to change. But even though lattice is more complicated to learn and there's a lot more features, it is very powerful because it allows you a lot more control.
The layout, is that part of ODS layout, or is that part of the procedure doing the lattice layout?
ODS layout is a separate thing. ODS layout works at a page level.
Right.
The layouts that she was demonstrating are just within the graph itself.
So you could basically have 4 graphs within an ODS layout and just
Correct.
go with
So
that.
you can literally have a panel of graphs and then lay out through 2 columns, another panel of graphs, and try to get crazy.
We have time for one last question. Wait for me. Trying to trip over your cord here.
Sorry, real quick, how do we get the slides again?
They are actually in the web on your mobile app right now. So if you go to your mobile app and you go to our presentation, you can click on that and then the PDF is right there.
Perfect, thank you.
Question?
But I'll be loud, Mike. Do you know the unit of measure for the gutter parameter? Is that like pixels or what is
I believe they're pixels, yeah. Most of the default is pixels you can specify the unit of measure. So when I was talking about all those attributes, and you can change attributes, that's where you can change if you want to do inches, or you can change that. But you have to specify the corresponding attributes. So like when I said seg label adders or value adders, you can change those attributes if you need to, but by default, they are pixels.
All right, let's show our appreciation for these ladies.
Questions later, you can email me because I love graphs and I will love to help you with your questions.